Hi guys, Math with Babs here. So this is our second video. I don't know why I keep picking soccer days to do videos. So kids are in bed. It's 9:45. Doing this video, getting ready for you guys tomorrow. Alrighty, so we're gonna go ahead and get started. This video should be a little bit shorter than the other videos that you've watched. So we're getting into real numbers, which are rational and irrational numbers. So what I wanted to go over with you guys first was the difference between a rational and irrational number, because you might not know that part. So go ahead and make sure you have your Cornell notes. Your title is going to be real numbers, rational versus irrational, 7th grade, pre-AP or GT, depending on what class you're in. Go ahead and put your class period and then put today's date. Remember, I printed off the wrong Cornell note. So where it says keywords, there's actually an Avid logo there. So you're going to write your words in this little skinny section right here. Alrighty, so the words we're going to go over: rational, irrational, Venn diagram, and real numbers. And I actually, thinking back to it, I don't think we get to Venn diagrams in this one. All right, so we're going to write a couple of definitions. Real numbers are a set of rational and irrational numbers. Irrational numbers are numbers that can be written as a fraction. So I brought my calculator here, and I'm hoping that you could see that. So if I have the number, let's see here. If I have the number 0.8, it is as a decimal. Can you see that as a decimal? If I turn it into, if I go onto my calculator, okay, I just plotted something that I don't need to plot. If I go into my calculator, this is acting weird. I can actually turn it into a fraction. So I would go, let's see here, math, fraction, and it's actually written as 4/5 as a fraction. But if I have the number pi, so I put the number pi in my calculator. If I try to turn that into a fraction, so I'm trying to turn it into a fraction, when I press enter, it's going to give me it as a decimal. That means it cannot be turned into a fraction, which means if a pi is an irrational number. So an irrational number are numbers that cannot be written as a fraction. Go ahead and add your question here. Remember, we talked in the last video, I think that I gave you a couple of the questions there, but you're going to start coming up with your own questions. Those of you that are an Avid are going to get really good at this section, because that's something that you're definitely going to learn. All right. So we're going to go through and list some numbers that are rational and some numbers that are irrational. So 8.5 is rational, because 8.5 can be written as a fraction, which is 8.5. Or if I did my calculator and I said 8.5, if I wanted to turn it into, let's see here, if I can remember how to do this. Dang it, I keep doing the wrong thing. I think it's alpha. Let me see if I can do this. I could turn it into an improper fraction. So if I wanted to turn it into an improper fraction, I would do 8 times 2, which is 16, plus 1, which would be 17 over 2. Okay, so that would be written as an improper fraction. So that would still be considered as a fraction. And I don't know if I'm going to be able to erase this, because, oh, here's the eraser. It's like, I don't know if I have the eraser. All right, now square root of 36 gets a little bit tricky, because I know you're kind of looking at it like, that one looks really weird. But if I take my calculator and I put square root of 36, so I'll put square root of 36 in there. When I press enter, it gives me 6, because 6 times 6 is 36. Now, any whole number can be written as a fraction. All you would have to do is you would put that number over 1. And voila, we have a fraction. So even though this one looks kind of tricky, I just know that this is actually 6. Sorry, that looks weird. 6 and then it would be 6 over 1. So I want you to definitely make sure that you add this section right here to your notes. Add that. So that when you go back and look at your notes, you know that square root of 36 can actually be transformed to 6, which gives you 6 over 1. Alrighty, going on to the next slide. Oh, so I already put that on there. So 8 and 1/2 can be written as 17 over 2. Let me erase that so that you guys can see that. This erased. Okay, so we already said that was 6 over 1. And then we talked about if I turn it into an improper fraction, it would be 17 over 2. Right. And then 6 over 1. All right, so both are rational because they can be written as a fraction, which we already talked about. Go ahead and make sure you have all that in your notes. Okay, so now we have some irrational numbers. So if I were to put square root of 24, put square root of 24 in there and press enter. I think I can turn this thingy and make it mirror. Okay, and put square root. If you notice, I get 4.898979406. Okay. If I wanted to write that as a fraction, hold on. If I wanted to fraction. Okay. If I wanted to write that as a fraction, I would press enter and it's going to put it right back in a decimal. Now, I already know looking at this number, it's not going to turn into a fraction because there's no pattern. So if you look at the numbers behind the decimal, you have 8989, and at first it looks like it's going to be a pattern, but then you have 79486. There's like absolutely no pattern to it. If you have a number and there's no pattern to it after the decimal, it's not going to be able to be written as a fraction. And then we already talked about pi. Again, if you look at the pattern, it's 3.141592654. There's absolutely no pattern. So that won't be able to be written as a fraction either. I think I switched that back. All right, so we have the numbers here, 4.898979486. Again, there's no pattern. That's pi when you turn it in. Both are irrational because they can't not be written as fractions. And when written as a decimal, there's no pattern. So it has to have a pattern. All right. Okay, go ahead and add your question there. Oh, we do get into Venn diagrams. So we have Venn diagrams here. So on our Venn diagram, you notice that you have rational, which is right here. We have irrational, which is over here. And then we have integers, which integer is going to be a positive or a negative number. That's not a decimal. I'm sorry. Yes, that's not a decimal. Actually, go ahead and write that on your notes because I didn't add that on there. I don't even think that I can type on here. So, yeah, I don't think that's going to work. So I want you to add, you see how we have real numbers, rational numbers, irrational. I want you to go ahead and write, let's see here. Let me go to the next slide and see if I wrote anywhere. Yeah, okay. So I want you to write over here. I want you to write integers. So you're going to write integers right over here, I, N, and then keep going. I'm not going to write the whole thing. Okay, and then I want you to add in your definition. An integer is a negative or a positive number that's not a decimal. So if you see that you have these weird ones right here, and this is like not big at all, I think that is, I can't tell. I actually cannot. I think that's 27 divided by 4. 27 divided by 4. And then we have negative 4 over 7. We have square root of 4, which is weird because you wouldn't think a square root would be a whole number. But if I do square root of 4, square root of 4 is 2. So 2 is a whole number. And again, I did square root of 4. Square root of 4. Sorry, it's backwards. It's going to be 2. Sorry, it's backwards. So that ends up being a whole number. So anytime you have a square number, a square root sign, you need to make sure that you actually write it all the way down. All right, so I'm about to run out of time on this, so I'm going to try to hurry up and scooch this time in. Okay, so then we have, go ahead and add your question there. Think you got it. All right, you are going to add those numbers in here. Okay. Add those numbers in there. See if you can figure out where they go. And am I going to make it? And then add your summary and Babs